Okay, good morning, everybody, and welcome to this university. It's not a lab, it's a university, so you won't have to use your laptop.
Yeah, sorry, there's a typo on the title and the abstract. It's a university on CDI, not a lab on Forge.
So we will show you a lot of stuff around CDI, with Forge, with live coding, and we'll have each one of us a role. So, oops, it's stuck, sorry. Okay, so I'm Antoine Sabot-Durand. I'm working at Red Hat. I'm the spec lead of the CDI specification, working on the CDI 2 spec at the moment. You can reach me on Twitter with this handle. Go to my blog when it will be up again, and grab code on CDI and other related stuff on my GitHub. On this university, I will play the role of the guy who say what to do, because in a project there is a guy who does things, and the guys who watch the other guy and say, okay, do this now.
So Antoine will be the master, and I'm Antonio Goncalves, and I will take the role of the dummy, the guy who doesn't know what to do. Other than that, I'm a Java champion. I have, my website, Twitter account, and GitHub project like everybody, and also a lot of stuff on CDI and Forge.
So we'll have a lot to cover during this 3 hours university. Even with that, you won't see all the stuff about CDI, but we will try to show you most of the interesting stuff and in a lively way. So all the university will be built around a nice application to manage your expenses, and I think it's time to describe this application, the expenses application.
The expense EEs. So the idea is we're going to show you a lot of CDI stuff, but not just doing hello world, because it's a bit boring, but actually having a web application and adding more and more CDI things. Not for technical purpose, but always for a user point of view purpose. So we want to show you what questions answer CDI. So this application will be a Java EE 7 based application with the CDI, JPA, JSF. We will also have a REST endpoint, and we'll integrate with code that doesn't belong to us. We will show you how to do that with CDI extensions. So we took the idea of the expense EEs web app is because we are here at Devoxx, we are here at a conference, and we're going to do expenses, and then our company has to pay the expenses back.
I hope so.
I hope so. So we're going to create this application, add more and more features, add more and more CDI things. So here we just show you a few screens so you get used to what we will be building. So it's a web app, and when you arrive on the home page, there's nothing. So you need to log on, use a password, or create a new account. Once you logged on, there's actually your part when you create your expenses. So that's what we show the user. So as a user, you're going to be able to create new expenses and view your own expenses. And the administrator, so your company, will be able to change the conferences, see all the expenses, and so on. So there's roles involved. And so here you can update your profile, of course. Then, as a user, you choose your conference. I'm here at Devoxx Belgium. The currency is in euro, and then you add expenses. I've been to the hotel, I've been to the restaurant. So it's like a wizard. You add more and more expenses, And at the end, you have one page that tells you, here are the 3 expenses that you've made. You want to be reimbursed in euros or in dollars. You confirm, and that's it. You can then have a look at your own expenses. And the administration part, it's your company, can have a look at all the database, basically. So in terms of model,
it's quite simple, yeah.
It's quite simple because we don't want to do it too complex either. Not an hello world, but not too complex. So we will have JPA entities. So one for the users, my expenses, his expenses, so I'm a user. This user goes to one conference, Devoxx Belgium, Java 1, Devoxx France. And this user does a lot of expenses. And as you can see, an expense has a type. Is it the train? Is it the transport, hotel, food? An amount. And then you ask to be reimbursed. So a reimbursement is a set of expenses. So this is the model that we will be using. As you can see, there's one-to-one, one-to-many type of relationships. So how are we going to do that? You know, we have 3 hours to create a Java EE 7 web app. How are we going to do that?
Yeah, I wonder how we're going to do that.
I wonder how we're going to do that in 3 hours. Well, let's start with JBoss Forge. Let's quick start our application. JBoss Forge is a tool for generating code and scaffolding code. So I'm going to use it either in a shell command or with the IDE integration. I won't go too much in detail in the innards of JBoss Forge, but think of it as an engine, and the CLI command, the command line interface, is just a plugin, and you can also have a plugin for IntelliJ IDE, Eclipse, NetBeans, and that will help me to start up this web app quickly. It takes care of integration, so for Java EE 7 app, I need a beans XML and a persistence XML and web XML, so he's going to do all that for me. And we're going to use it only for Java EE. But JBoss Forge is extendable, and there's add-ons for Angular. There's even one for Spring Boot. There's the guy who created the Spring Boot add-on here. So JBoss Forge can scaffold a lot of different technologies, but we will use the Java EE.
You forgot to mention Wildfly Swarm as well.
Yeah.
Add-on.
Yeah. So the way we're going to do it is I'll do most of the typing, and Antoine will do most of the talking. So now I'm going to create this web app with Forge, okay?
Yeah, in a magical way.
In a magical way. So let's switch screens.
Okay.
Is it okay?
Yeah, it's great.
Can everybody see all right? Yeah? The font is big enough? So I'm going to start using Forge in a command line interface. So you download Forge, you'll execute it. I'm using the latest, greatest. And then if I press tab, I'll have several commands that I can use. I will show you the same thing with IntelliJ IDE. So everything starts with a project. I give it a name, so expenses. And JBoss Forge has created something, a project. Not very exciting until here, but if I take my IDE, so now I'll take IntelliJ IDE, and I'm going to show you what Forge has created behind my back. So I import this new project. Called expenses. it's a Maven project. By default, Forge creates a Maven project, but you can ask him, you can ask it to create a Gradle project too if you want. So I take all the defaults of my IDE, and so this is what project new does. It just creates a Maven structure with a POM XML. So by default, it uses Java 7. By default, it creates a WAR file. If I wanted to create a jar, I will just use a type, and I will say, I don't want a WAR, I want a jar. So I can create, JBoss Forge will mostly take default decisions, but I can tell him, I don't want this, I want that. So now that the project is created, we've said that there was an entity called conference. So with one command, Forge will install JPA and create my entity. What does this mean? Is I import, because the POM XML has changed, now it depends on Java EE 6 and JPA 2.0. And Forge has created a persistence XML by default using Hibernate, but I could tell him I want something else. I want Eclipse Link or something. And an entity called conference. And again, by default, it has created an ID and a version. And I can say, yeah, but a conference has a name. So I can say name. So with one command, Forge will add an attribute of type string by default. And I can say country. And again, it will add code to my existing classes. And then, you know, I can say, yeah, but, you know, I need an entire web app. So by default, you can set up a scaffolding. So I only have JSF add-on installed. So faces, but this is where you can install different add-ons and say, no, I want to scaffold an Angular application. So because it's the default, I don't even have to do that. And I go generate an entire web app depending on conference. And here, plenty of things will happen. Forge will install CDI, EJB, servlets, and it will create all the needed plumbing. So it has create templates, scaffolding, beans XML, faces config. So now everything is up and running.
Wow, that's magic. Can we see the POM.xml right now?
The what?
The POM.
And the POM XML has been changed with all the dependencies.
Oh,
so now it uses JPA2, CDI, EE, JB 3.1, and so on and so forth. So I can create this web app using the command line, but I'm going to do something a bit more clever. Well, I'm going to cheat a little bit, actually. So I'm going to destroy what I've done. So Forge has created an expenses. I'm going to delete that. Expenses. And what I'm going to do, actually, is execute a script. So I've cheated a bit. Oh, I should have increased that before. Because what I really want is a Java EE 7 app. And so here I've run a script where I change all the versions of the specs. I've created an enumeration with user and admin. Remember that in the expenses there's the admin role and a user role. A couple of entities, and I will scaffold in JSF and a REST endpoint. So here is a script called init fsh. And what I can do actually is run Forge and tell him, please execute this script. So that's a handy way. See if I go run init. Now Forge will create the web app, set up the persistence layer to 2.1, create all the entities, create all the enumerations, and at the end scaffold the entire app with JSF and with JAX-RS. Voila. So this time, if I import this project, so I go back to where I was, except now there's a bit more code. Again, I take all the defaults. JBoss Forge has created a flat architecture. I will show you a few slides after. So here is the conference with the name, with the date of the conference, with the country. The currency, we have dollars and euros. Expenses with enumerations here. And of course the reimbursement, which is a one-to-many expense and one-to-one and many-to-one conference and many-to-one user. So JBoss Forge has created all that thanks to the script. A REST endpoint. So here I have a REST endpoint that does CRUD operations on my conference, so I can expose it. And the view. So now I have backing bins for all the CRUD operations on my entities. So
you can deploy it.
Yes.
Yeah, great.
Let's see if it works. It should. So I'm taking Wildfly, the latest Wildfly 10 CR4. I deploy this WAR file.
And cross fingers.
So I could have typed that, but it will have taken a bit more time. So just running the script, no extra magic. And it should work.
Yeah.
So here I can do CRUD operations on user. So I can say, I can type a password, okay, a name, an email, and I can choose a role. So let's say I'm a user. So here I've created a user in the database. So there's actually a H2 in-memory database setup as default. Forge does that as a default. And I can do CRUD, so I can read it, edit it, change the name, update it, go back to the list, create a conference. Oops, sorry. Devoxx B, which is in Belgium, Antwerp. Save. And then I can create a few expenses, saying 3 nights at the Marriott Hotel. I give it a date, how much it costs. It was a hotel, and it was in euros. And when I need a reimbursement, just to show you the one-to-many that Forge has created, I can actually pick up one expense, add it, so as many as I want. This is the way JBoss Forge does it. Take the user, the conference, so that's a one-to-many, and save it. Okay, so JBoss Forge has created a CRUD operation that basically allows me to change all my entities with a web app. And also, it has created a REST endpoint. By default, it's called RESTs. Conferences, there's one. If there was many, it would have listed. And JSON by default. So as you can see, Forge has created an entire app. and with the following structure. Quite a flat architecture, because on the top you have you have all the CRUD pages, so you can create an entity, update it, view it. With JSF backing beans, so quite flat. The backing bean deals with the database and so on, and my entities. So this is what Forge has created.
Yeah, it's a very nice way to bootstrap an application in Java EE and do a lot of stuff without, how to say, little knowledge. But now our application is not quite yet finished. We only have a CRUD application. We don't have a nice way to create our expense. There is no way to log in and log out and give rights, grant permission to users. And we have a default look and feel. We'd like to have something, how to say, more pretty. And as Antonio said, we are only using Java EE 6 at the code level, even if we upgraded all the libraries. For the moment, Forge only generate Java EE 6 code. So we'd like to upgrade our code to Java EE 7, to have effective Java EE 7 code. That means that we could use the new feature, especially in the GTA 1.2 with the @transactional annotation, @transactional interceptor usable on the CDI bin. We could also upgrade to GPA 2.1 to have all the feature to insert data in the database at the deployment of the application. And we didn't go deeply in the generated code, but right now it's not a full CDI programming model application. So we have a flat architecture, like Antonio says, and we probably would like to have something more three-layer architecture. So let's try to fix that and to go for a refactoring of the application.
So that would have taken me a few hours, I have to say. But so we've cheated a little bit. So I'll go back to the demo.
It's the second time you are
cheating.
Yeah, I am counting them.
A bit of a cheater. So, as Antoine said, Forge is Java EE 6, and we wanted to have Java EE 7 so we could add more CDI features. So the application is still the same, okay? I still have the same thing, except there's data in the database. So now I have a set of conferences. I have a few users, reimbursements, and so on. So the application looks the same, except in terms of code, we've changed some things. First of all, we went full EE 7. So here we are using Java EE 7 because Forge only does EE 6. And we upgraded everything. JPA 2 to 2.1, JTA. JTA is nice because it allows us to do something like that. So we've created a layer of transactional services, and thanks to JTA 1.2, we can use @transactional instead of EJBs, instead of having 8 stateless. And we will dig a little bit into that later. What else? Well, JPA 2.1 allows us to run a SQL script, a startup. So here, we insert data into the database. That's why when we deploy, we have something like that. You know, this script will be executed during deployment, not before, during. Other than that, we haven't, because we've added a transactional service, our backing beans have changed a bit. Our backing beans inject the service instead of dealing with the database. So, actually, it's not me who refactored that. It's Antoine, who was thankful enough to do that. So there's few things here I don't really understand, and I don't really know how it works. So here I have my JSF backing beans, and when it needs a service, it uses this annotation called @inject. So, you know, I'm the guy who doesn't know much about it. So I turned back to Antoine and said, Antoine, please, can you tell me what is this @inject?
This @inject stuff, yeah. So let's switch again. So if we look at the new architecture of the application, so we added a service layer, and if you, I'm not sure if, yeah, you can see that we are injecting this service layer in our backing bean. Previously, we had this flat approach, so we add this new layer to be able to have something more, how to say, more modular. So what about this @inject stuff? In fact, it's the good occasion to give you an introduction to the CDI specification. So what is CDI? So I think everybody here heard about CDI. Who is using CDI right now in day-to-day development? Great. CDI 1.1 or 1.2? So you're only on CDI 1, okay. So we are going to show you CDI 1.2 code, and at the end a little bit of CDI 2 code. So CDI is a Java EE spec. It's a spec that is one of a few specs that is under open source with an Apache license. It was launched with Java EE 6 years ago, nearly. Yeah, 6 years ago. And since the first version, there was already two releases. So the last release is the 1.2, which will be included in your Java EE 7 application server. And we are working on the new version of CDI, CDI 2, which should be released in the first half of next year. So we've got two major implementations for CDI. JBoss Forge, the reference implementation that we'll be using during the university, and another implementation coming from the Apache Foundation. So it's the Apache Open Web Beans implementation. So what do we have with CDI? In fact, the first thing with CDI, the first feature of CDI is to give you a very powerful programming model for your application. It gives you the capacity of applying lifecycle to your components, to your stateful object. You have a dependency injection mechanism, so all the @inject stuff that Antonio didn't understand comes from here. The particularity of this dependency injection approach is that it's completely type safe. So we'll go back on that, but everything is based on type regarding injection in CDI. You've got all aspect-oriented programming features like decorators or interceptors, so you can decorate your components or intercept your components. We will show you this feature later as well. And you also have a nice feature that is very popular in CDI. It's the event bus included in CDI. So you have an observer pattern included with an event system allowing you to add more decoupling to your application. So I can broadcast an event. I don't know if another component is listening, but if one is listening, it will catch the event and do something. And probably the most killing feature in CDI is the SPI included in CDI. It's probably the first Java EE specification including such a deep SPI. So we have a system of portable extension included in CDI, which allows you to extend the platform to integrate third-party framework or to have a better integration with other specification. And it's said portable because it's a way to extend the platform, but on all the application servers supporting CDI, you will be able to use the same portable extension without any specific stuff. So if you had to explain CDI to your boss, you can use this sentence. In fact, it's a way to add a powerful and modern programming model that brings you good practice and standardize them. You have a very invisible way to bring consistency and add third-party technology to your application through this model. And when you have switched to CDI, you have a kind of invisible backbone on your project that you can use to add new stuff and go very, very far. The first thing you have to keep in mind when using CDI is the fact that everything is done by the CDI container. So it's the art of CDI. So the container has a lot of things to do during the deployment of the application. The CDI container checks a lot of stuff at boot time. But unless you're doing a portable extension and add-on things, you will never see the container. So it's something invisible that do magic things for you. So it manages the life cycle of your component. And it's a kind of conductor for your application. So that's for introducing CDI. Now, I go back to Antonio's question. What about this at inject annotation that was added to integrate this service layer? In fact, in CDI, almost everything is a bin. So when you deploy your application, the container scans each class and check for a list of rules to see if it met the condition to become a bin. So these conditions are very loose. There are a few corner cases where a class cannot become a bin, but so must Pojo can become bins. For instance, here you have a very basic class, hello service class with one method, hello. It will become a bin. So now you know that you have bin and that your CDI containers discovered them at the boot time. You can use this inject feature. So in CDI, you can inject a bin into another bin with the @inject annotation. So here we are injecting the hello service bin I defined before in a field. You can also do this in a constructor. So you can add the @inject annotation on one of your constructor. And when you'll ask for an instance of this bin, the container will call the constructor with the required bin at the injection point to call the constructor method, and will instantiate the bin with that. You can also use the @inject on a method. So it's a way to say, okay, when you will instantiate this bin, you'll have to call this method or this method if you have multiple methods annotated with @inject, and this method are called initializer methods. So it's another way to add injection in a programmatic way after the instance was created, after the constructor was called. You have to keep in mind, Antonio, that there could be only one. When you define an injection point, it will be checked at runtime. So the type of the injection point and other information we will see later will be checked at boot time. If you have an injection point and there is no bin eligible for this injection point, so no bin coming from a class defined at the injection point will be said unsatisfied. If there are multiple bins that can be eligible for this injection point, it will be said ambiguous. And in both cases, you've got a deployment exception at boot time thrown by the container. So the idea of CDI is to have a very type-safe and static approach. There are corner cases, but in, let's say, 95% of the case, you'll have all your errors at boot time, at deployment time. So you'll know that you have a problem in your code when the application is deployed and not at runtime. And I think now it's time to go back to our demo.
Okay, so I think I got it. My use case now is I want to add some logging. When I create a new user and I do the persist, I want to add a logging message. So for what Antoine has said, it looks like it's quite easy. I just go @inject, private, and I have the Java util logging, that's fine. So I'll call that a logger. So I inject a logger, and here I can go logger info, user persisted. I'm gonna, so I can see it in the logs, and I'm gonna give the user. Oh. So now each time I'll be creating a user, I'll show the log. So I'll redeploy the app again, and this should work.
Yeah, if it works, I pay you a beer.
Oh. What happens? Unsatisfied dependencies for type logger with qualified default.
Yeah, you didn't watch my last slide.
Oh, that's funny.
Regarding.
So why it's not working?
Yeah, because yeah, when I said that everything is a bin.
I thought it was a bin.
Yeah, in fact, it's everything in your application. So all your code is a bin, and all the code that is packaged in a certain way as a bin archive, so there should be some info in the archive to be sure, will become bin. If you take the class coming from from Java, the JDK, there won't be a bin out of the box. For that, you'll have to use a nice feature coming from CDI. That's the producer thing. So when you have a class that you don't own, that comes from somewhere else and that wasn't thought to be a CDI bin, you can use a producer. So a producer, a producer is another way to declare a bin. So we saw in the previous example that we can declare a bin with a class. But you have this new way to declare a bin. You can declare a bin from a field or a method with a producer. You can do that to expose a class that you don't own as a bin. So how to do that? You have to declare your producer in an existing bin, so you have to add annotation in an existing bin, and you'll add the add produces annotation. So you can add the add produces annotation on a field. So here you have, for instance, a list. So it's a class coming from the JDK, an interface coming from the JDK. So here I'm producing a bin of type list integer. Or you can add it on a method. So you can define a method that returns something, and the return type will be the type of a new bin. Here there is a little additional feature. You can add meta information on the producer like qualifiers, but we will speak of qualifiers later. So, as I said, producers are another kind of bin. There are other kinds of bin after producers and standard bins, but the two major bin types you will be using is the managed bin coming from the class and the producer. So when you have defined the producer, you can inject the type And when the container will try to satisfy the injection point, it will be using the producer, either the field or your method you define with the add producers annotation. So here you have an example. You can use it on a field, you can use it on a method, etc., etc. Sometimes when you use producer, you are taking code that can do heavy stuff, allocate resources or, I don't know, file or something like that. So you can define a kind of housekeeping regarding the producer that will be the disposer. So you can define the disposer for each producer. So here, you can add a method with the add disposers annotation on one parameter. And this method will be called when the container will need to release a producer, to destroy a producer, to help you releasing resources or other things. Another good stuff to know is that your producer can have parameters. If there are methods, you can add parameter to this method. That means that when the container will produce the bin, it will check the parameters and inject them. So here you have, in this producer, you have parameters of type mybin. So the container will look for a bin of type mybin, resolve it, and use it to call the producer method to produce your bin. So you have injection points in each parameter of your producing method. So now that we talk about producer, you know a new stuff, perhaps you can do something with this new feature.
Okay, so in my understanding, I do not own the Java util logging, so the logger is not mine.
Yeah.
So it looks like I have to produce it. So I need to create another class. So a Java class, I can call it whatever I want. Logging,
whatever
producer.
My universal producer.
Okay. I can put it anywhere I want?
In your project, yeah.
In my project, okay.
You can call it, let's have some fun.
So call logging producer. Okay, so what I need to do is create a method, private, public, protected?
As you want. It can be
private, so it will return a logger. The method is called wherever I want?
Yeah.
Produce logger.
The important part is the return type of the method.
Okay. So here I just go return logger get logger, and I give it a name, my logger. And I produce it.
Yeah.
So I go produces.
Produces, yeah.
And that's it.
Yeah, and when you do that, the container will check this code at boot time, and we'll see that there is a new bin, and how to produce this bin, I will use the add produces annotation.
Okay.
There.
So now, if I create a new user, let's say new.
Very interesting.
A user. So here I'm creating a new user, and I should see my log then. Yeah.
Right.
User persisted.
Okay.
So that's good. Except here I have a.
You ask the limitation about the method. You can even have a static method as a producer method.
Okay.
So you can go very far.
Okay.
Like that.
So here I just have one problem is no matter where I inject my logger, the logger is called my logger.
Yeah.
And it's not cool because I wanted, my logger injected in user service to be called user service. So can I do?
Yeah, I have a solution. I have a solution for you. Yeah.
No?
Yeah. Try.
This get class, get name, maybe.
Yeah, but you'll have the get class and get name of the producer logger method. You can try that.
Oh, okay. So if I need to create a new.
Perhaps you should have restart your application, no?
I did.
Magical.
Oh, it's called logging producer.
Yeah,
that's really not what I want.
Yeah, it's the class. It's the current class where the producer is
Okay.
created.
So how do I do that?
Yeah, you've got a trick for that.
Oh.
So, as I said, you can add parameters to your producer method. And one nice stuff is the possibility to inject metadata about the injection point where the logger was injected. So you've got this SPI interface injection point, and you can add the injection point as a parameter of your producer. And with this metadata, you can know where the logger was injected. So you can retrieve the class where the logger was injected and build your logger with this information, like I show there. So you can try to add this feature to your code, perhaps.
Okay. So what I'm going to do here is go injection point. So that comes from the JAVAX Enterprise inject SPI. Call it IP. So now I can do IP got member, that's what you said.
Yeah.
Got declaring class, so that's the class that is injected, and I want the name. So this should work?
Yeah.
Okay, so let's go back to user again, create a new user.
I hope it will work.
Oh, okay, now I have the user service. So here I have the name of the, so now I can go to my conference service and do the same, inject the logger, and I can go somewhere else and do that again and again and again.
And as you see, you don't have to add information at the injection point. You only have to add the injection point, and the producer will detect where it is injected and construct the producer with the right information coming from the injection point metadata.
Well, that's nice. Except, you know, if I want to log all the methods, you know, because I want to add a bit of debugging, a bit of, so I have to inject my logger.
I give you that, you want that. There is a solution for you. The solution is to use the AOP feature coming from CDI. So here we'll probably use an interceptor to do that. In CDI, you have two AOP features. You have the interceptors that Antonio will show the usage in coming minutes, and the decorators. So it's important to understand the difference between both features. So of course, both are aspect-oriented programming tools, so you can use them to enhance code in an orthogonal way. The difference is that interceptors are more technical-oriented. So it's very useful to do things like Antonio would like to do, logging, or doing stuff like transaction, doing stuff like security, and so on. When you create an interceptor, you bind the interceptor to a class or a method, so a bin or a method. The decorators are more business-oriented. The difference is that the decorator knows about the code it is decorating. For the interceptor, it's more complicated. He knows about the context it is decorating, but it doesn't know about the business nature of the bin. Decorators are not bound to a specific, to a given set of class. It is bound to a bin type. So you can say, okay, I decorate this bin type. The things to know about the good things to know about interceptor is that they are defined in their own specification. So there is an interceptor specification, and CDI uses this specification and adds a few stuff to the spec. To create an interceptor, so you'll have to create an annotation, which will be the interceptor binding. You'll have to create a class for the interceptor to define the intercepting code, and you'll have to bind this interceptor class to the interceptor binding by adding this binding to the class. So in the class, you will define intercepting method to say, okay, when this interceptor will be called, this code will be executed instead of the original code. You have a certain list of life cycle phases to intercept. So you can do interception when the bin is constructed, when the bin is destroyed. But most of the time, we'll use the around invoke lifecycle. So it's a way to intercept method invocation. And you will also use the interceptor binding at the other side of the interceptor feature. It's on the bin or on the method you want to intercept. So to be more clearer, a little example. So when you want to create your interceptor, you start by creating an annotation, and you will annotate this annotation with the @interceptor binding meta annotation. So here, I'm creating a loggable annotation, and I'm adding the @interceptor binding to say, okay, this annotation will be an interceptor binding. After that, I will use this annotation on a specific class. So here I have created a class called log interceptor. And I have added to this class my binding. So you see the second line, I have the @loggable annotation. And I also added the @interceptor annotation to say, okay, here it's the definition of the interceptor. It's not a bin that should be intercepted. So it's the way to say, okay, here is the definition. So I bind the interceptor to the annotation with this mechanism. And in the class, I define the method to call instead of the code that is intercepted. So here I have a specific method with the annotation @around invoke. The method signature is something you have to respect. You have to be careful about that. So I get a parameter which is the invocation context. And this invocation context will give me a lot of information about the method I am intercepting. So here you see, I can use this invocation context, to get the method name I am intercepting. After having logged the name of the method, I can say, okay, now you can execute the code of the invocation context. And finally, you can log another message when the context was proceeded. So it's rather simple to declare. So you'll use the interceptor this way. So you'll add the interceptor binding on bin class to say, okay, all the method of this bin class will be intercepted. So all the method of this bin class will have a message before execution and after execution when they are called. And you can, of course, only bind it to a given method. So the second AOP tool you have in CDI are decorators. So decorators don't have specific specification. They are a CDI feature. So to use decorators, your bin should implement an interface. When you define your decorator, it will implement the same interface that the bin you want to decorate. You will add the @decorator annotation on your decorator to say, okay, it's a decorator. As you implement the interface, you may want to only decorate one or two methods, so you can declare your decorator as an abstract class to only overload the method you want to decorate. And you will inject the bin you are decorating in your decorator. So it gives something like that. So here I have a decorator which decorates all the bin of type hello service. So I have defined this decorator with the @decorator annotation. I have added, I skipped that on the interceptor part, that you can give a priority to your interceptor and decorator to say, okay, it will be executed in a specific order. And the second effect of that is that it will be enabled for all the application. So here, I am injecting the bin I'm decorating. And now I can override a method in the bin. So, in fact, the hello service bin, when I will call the hello method, it won't be the hello method of the original bin that will be called, but this method, the method here, which will take the hello method of the original bin and add decorated at the end. So now we have an introduction decorator and interceptor. Perhaps you can try to use the interceptor stuff.
Okay, so my use case is I want to, display a log on every method call. So it looks like it's an interceptor, not a decorator.
Yeah, because it's more technical.
So I know that with Forge, so here I'm using the Forge integration in the IDE. There's actually a command to create a new interceptor binding. So that's going to save me a bit of time.
It's convenient.
And I'm calling it, as you say, loggable. Sounds like a nice name. Hey, that was quick. So this is an interceptor binding. It's just an annotation, an empty one, called loggable. I put it in the bins package, but I've put it. I could have put it, anywhere. So now I have the loggable. Wait a sec. Let's take a photo, the two of us.
Thank you.
Okay, guys, go back to work. So now I have my interceptor binding. This rings a bell because in Java EE 6 and even before, prior, 5, there was this thing called an interceptor. So here I have a logging interceptor, that does the around invoke. That comes from Java EE 5.
Yeah.
So it intercepts each call before it logs something and proceeds to the intercepted chain until the target. And then on the way back, it logs the exit of the method. So that was the old way of doing an interceptor. Now, I'll go, if I follow you, loggable.
Yeah.
And I also have to tell that it's an interceptor.
Yeah.
So now I have this interceptor binding that has this name loggable. I have the code that implements this loggable interceptor binding. So now I can go to my service and go loggable. So here I log all the methods of the conference service and the user service. So I do loggable. But because I wanted to, put the logs and take them out and put them in, I'm not going to use the priority. I'm going to go to the bins XML and actually activate my interceptor. So now I have my interceptor binding. I have my interceptor. It's enabled. So if I deploy this app, I should have logs in all the methods, entry and exit.
I hope so.
So I deploy the app. And it logs all the methods because I've put the interceptor binding at the class level.
Yeah.
And so now if I go user, create new, or even search or find, okay, cool. I have conference, etc. So each time I have a log. So it all comes from the abstract service. It's not that great.
No.
Not that great. Well, let's leave that maybe for
we will see that
later. Let's fix that.
There is a solution.
There is a fix?
Yeah, there is a fix.
Good. But, okay, so now, so we will fix that later.
Yeah, we'll fix.
So let's go back to the application. So now there's something missing. I want to log. Okay, I want to log with a username and password. And so the company gave me a couple of classes. Then one encrypts the password with the encryption algorithm, and one that doesn't, because we have old passwords in the database that are not encrypted. So I have these two encryptions algorithm, and I want to inject one for one purpose, and maybe the other one for another purpose. So, okay, I got the at inject, but how can I say inject the encrypted password rather than the clear password? How do I do that?
Yeah. That's an interesting question. Yeah, we talk about a strong typed approach in the injection dependency injection engine in CDI. The problem with this strong typed approach is that we can have ambiguous injection point. You can have two bins with the same type, and you don't have a solution out of the box to say, okay, I want this bin and not this other. But you have this solution. It's qualifier. So what you can do when you have this problem, here we have an example. So we have two bins. So we have a French hello service and English hello service, both of them implementing the hello service interface. And I want to inject the hello service in a third bin. So when I do that, I will have an ambiguous dependency error at boot time. So the container will detect that there are two candidates for this injection point. So what I can do is to define a qualifier. So a qualifier is an annotation. So in CDI, everything is annotation for the configuration. So it's an annotation having the meta annotation at qualifier. So here I define two qualifiers, one qualifier at French and one qualifier at English. Now that I define this qualifier, I can use them on my bin. So I can add the at French on the French hello service and the at English on the English hello service. And of course, I will be able to distinguish them at injection point as well. So I can have both implementation of the same interface, inject the interface, and have a solution to remove ambiguities between both services. So here, I use the at French, at English, at injection point. But as we are using annotation, and annotation are type, we keep the concept of strong typed injection, because we are adding extra information, but this information is also type. So you can have a more advanced qualifier. You can add members to qualifier. So we saw before a very simple annotation definition. We can put member in our qualifier. So here we switch our at French and at English to at language qualifier. So we define at language qualifier, and we have a member in the qualifier, a member of tab of name value to have the default way to define the qualifier. And the type of value is long choice, which is an enum with two values, French or English. And I have a second member here. It's the description member, a string. And I can add information in this member. But you see, there is another annotation on this member. It's the non-binding annotation. By adding this non-binding annotation, I'm saying, okay, there is this member in this qualifier, but this member won't be used in the injection resolution, it won't be taken into account when I try to inject or find a bin with this qualifier. So now I can use this new qualifier. Here it's a way to avoid having a zillion of annotation at French, at English, at Dansk, at Spanish, etc. So I have this qualifier with member, and I can decide to inject the different value in my consuming bin. And you see here we have the description member that we added the little message for the bin, and it is not used by the container to decide what bin to inject. Another nice feature is the possibility to add multiple qualifiers on one bin. So you can give different aspects to your bin to make it match your I don't know, your business approach, your way your application is designed. What you should know is that the injection point should have a subset of your qualifier and your bin definition. So here we have a bin with two qualifiers, language French and at console. I can use both qualifier at the injection point, it will work. I can use only one qualifier. I cannot use no qualifiers because it's a special use case and it won't work. And I cannot use an injection point with an extra qualifier that will be unsatisfied here. What's important to keep in mind is that we have a set of built-in qualifiers in CDI. I don't know if we saw code with that, but we have the @named qualifier that is a very special qualifier that say, okay, this bin will be able to be accessible through the UI. So it's the only, how to say, it's the only occasion where I can access a bin from an identifier from a string. So it's the way to get the bin from the UI. You have the @default qualifier, which is the qualifier that is added to the bin when the bin doesn't have any qualifier or have that name qualifier. You have the @any qualifier, which is added to all the bin and will be very useful when you do a programmatic lookup. We will see the programmatic lookup later, so you will keep in mind this @any. You will see it later. We have new qualifiers in CDI 1.1 with the @intercepted and @decorated, which allow you to inject decorated or intercepted bin in the interceptor or decorator. You have an @initialize qualifier, which will be used to observe specific event related to context when they are started or destroyed. So all the context in CDI fire an event when they are created. Using this qualifier, you can observe this event and do something when a specific context is created. And the same for destroy. So a few examples. So here, my first bin, so the public class my bin, will have the @default and @any qualifier. The second one will have the @default, @named, and @any. So I only added @named, but you will have the free qualifier on the bin. The third one will have the @language French, @named, and @any qualifiers. And the last example is about the injection point. So this injection point will have the @default qualifier. So we will look for a bin of type mybin2 with the add default qualifier, so without qualifier. Now that we saw the way CDI is doing bin type injection, dependency injection based on type and qualifier, perhaps it's the time to talk about the type of a bin. In fact, when you define a bin, the bin you will create will have a set of type, depending on its definition. You saw in the previous example, we injected a given bin from an interface, not from the implementation class we defined. So you have this set of bin for the set of class, defined for a given bin. For a standard bin, the set of type for the bin will be the bin class, every superclass, and all interface that it implements, and it will go until the object class. You can decide to restrict the type of a bin with the @typed annotation. So you can say, okay, I don't want this bin to have, I want this bin to have only this type or this type, in the hierarchy, of course. You cannot skip the object class in the type set. So if we take a few examples here. So here, my first bin, so the public class mybin, will have two types in its set, so the mybin class and the object class. The second one, the producer, in fact, so you see there is a producer, produce hello service, which returns an hello service object, which is an interface. So it will have the hello service type, the hello, and object. The third one will have as a type fr hello service, generic service of string, hello service, hello, and object. And the last example, which used the @typed annotation, in which we restrict the type to hello service class, will only have hello service and object as type. So you have a lot of tricks to limit the list of type for a given bin to be eligible in an injection point. You have to keep also in mind that in CDI, we don't have type erasure, so parameterized type count. So here, you have two injection points with a service of user and service of staff. CDI will see the difference and look for the bin defining this class. So if we get all this information together, when CDI perform a type-safe resolution, so when we try to resolve a bin for a given injection point, the container will take into consideration the bin type and qualifier. So if a bin, if there is a bin that has a bin type that match the injection point type, so that has a bin type in its set that match the injection point type, and that the bin have all the qualifier that are on the injection point, then this bin will be assignable to the injection point. So it's the basic mechanism of type-safe resolution built into CDI. But enough with theory. Let's go back to practice.
Okay,
so now that I explained you how qualifier works and how you can use them, perhaps you can use qualifiers to have your...
So, as I said, this digest password, I have an interface here called digest password with one method. It takes a plain text password and digests it. So that's an interface. And actually I have two implementations. The clear password, that's an easy one. You take the plain text password and return it. So there's no encryption. And the other one is the encrypt password. It uses an encryption algorithm. So both encrypt password and clear password implement the same method. So when I create a user, when I persist a user in the database, I want to take the password and digest it. So what I do is I inject the interface digest password, and now I have to tell him which one I want. Well, when I create a new user, I want to encrypt the password. So that's when I need a qualifier. So I'm going to use Forge again to be quick. And I'm going to create a qualifier called clear. So that's for clear passwords. Okay, so here it is. Clear, it's a qualifier. I can apply it on methods, fields, and parameters. That's the default of JBoss Forge. And I'm going to create a new one called encrypted. Encrypted. Okay. So now what I have to do is I have to go to the encrypt password and qualify it with encrypted, and the clear password with clear. And now, in my user service, I need to choose either one or the other. So I inject the encrypted. So here, I inject the interface, but the qualifier tells me not this one, the other one. And something when you were talking that I did behind your back is I went back to the logger. And you remember the logger wasn't very accurate because it was logging the abstract service class. So what I did is in my logger, I injected the intercepted bean, so the guy being intercepted. And in my log now, I go intercepted bean, please give me your name. So it's not the abstract class, it's the class that is being intercepted. So this is much more accurate. So if I deploy the app, and I create a new user, it should use the password encryption. So user, I create a new one, new password, new admin. So now, if I go to new, I can see that the password has been encrypted.
Encrypted, yeah.
That's good.
See what's easy.
That's good. But now I have a bit of a problem because, as I told you, our database has clear passwords. So here is the database.
For instance, yeah.
A Goncalves. The password is encrypted. But unfortunately, I have legacy data, and legacy Joe has a clear password. So now the problem is, in my database, I have the new users are encrypted, but the old ones are not encrypted.
Yeah.
So when I'm going to log user password, I want to use both the encrypted and the clear.
Yeah.
So because when I inject the encrypted, that's a bit hard.
You could inject both passwords.
Oh, yeah, I could inject both.
But it's not very...
And if there's a third one?
Then there is a better solution.
Okay.
Perhaps we will see it after
Let's go.
A short pause, no?
Teach me? Oh, after?
After?
Okay, teach me.
Okay. So what we'll need to use here is a very nice feature of CDI. So until then, we saw injection were resolved at boot time, at deployment time. But sometimes you need to choose your bin or resolve your bin at runtime. So you have a nice feature, which is the programmatic lookup. Programmatic lookup is based on one another SPI nice interface called instance. So this instance interface lets you perform this type-safe resolution at runtime. What you have to do is, instead of injecting a bin directly, so here instead of injecting hello service, you inject instance of hello service, and you have how to say, a kind of resolver around your hello service bin to perform a resolution at runtime. So after that, you'll use a method of the instance. So here you can use the get method to get the effective instance of hello service and call any method on hello service. Of course, that's the first use case, and the simplest one you can have. You can do things more interesting. What you can do is to check the bin existence at runtime. You know, I said before that at deployment time, the container was checking all injection point and so on, and gave you error if injection point were not satisfied. We have a solution to avoid that, is to use the injection of instance instead of injection of the bin directly, and do this resolution at runtime. Thanks to the instance interface and the method in the instance interface, you can check if the resolution is satisfied or not, or ambiguous or not. So you have method to say, okay, is it satisfied, is it ambiguous? And you can decide, okay, there is no problem of resolution, I can ask for the bin. So that's a convenient way to avoid a crash at boot time. Another nice feature of instance comes from the fact that it extends the iterable interface. So you can iterate on the possible instance of a given instance, how to say, instance interface. So here, I'm injecting an instance of hello service, and you see the specific at any annotation added. So I say, okay, I want to inject an instance pointing on all the possible bin of type hello service, regardless of their qualifier. So you remember when I create a bin, it has the at any qualifiers by default. All the bin have the at any qualifiers. So here I'm saying, okay, I inject all the potential hello service instance. And after that, I can loop on all these different hello service. And I guess perhaps it will be something like that you should use in your use case. You can go a bit further by specifying a qualifier in your resolution. So you can use a specific class coming in CDI, the annotation literal class, which allow you to create an instance for an annotation. You know, in Java, you cannot instantiate an annotation, so you have this annotation literal helper class that allows you to create an instance of the given annotation. So here, I use the programmatic lookup mechanism with the at French qualifier, and I say, okay, I want the hello service with the at French qualifier using the select method of the instance interface. So now I think that you learn enough to do things about resolve your password issue.
Okay, I think I got it, because here, you know, as I said, I inject the encrypted digest password. So, because every bin has this qualifier called any, I will go, instead of injecting the encrypted, I will inject the any. And that is not a digest password. This is an instance of a digest password. And because there are many, it's actually digest passwords. So that will inject me all the valuable digest passwords. So now what I do here is I loop through this password digest. There's two, the encrypted and clear, but they could have many more. And I find by login and password in the database, okay? If I find it, I break, it's there. If not, I loop again. So here I'm in debug mode. So,
and the beauty of that is that if you add a third digest password,
my code will not change. So here, legacy is a clear password. So if I sign in with legacy and legacy, in debugging mode, it will digest, it will loop through. This one is the digest passwords. So it will tell me that which...
You have all beans.
Yeah, it's all beans. And so it will find it. It was the first one. So then it will log me in. But if I go to admin, that's an encrypted one. So it will loop first with the clear password. It will not find it, and loop again, and then it will go, yes, it's the encrypted one. So that's a nice way with the instance any to tell CDI, inject me all the bins, and I will loop through them, and I will do what I need to do. So, okay, cool. Now I can log in and log out. Well, log in.
Log in, yeah.
Then I need to log out. Then I have other features, and I would also like to integrate that with code that I do not own. So maybe we will look at that after 15 minutes break. It's 3 p.m. sharp. Let's come back in 15 minutes, 3:15, and we will go through context, events, and extensions. And also we will finish with some CDI 2.0 features. Okay? 15 minutes?
Yep.
Welcome back, ladies and gentlemen, for this CDI University talk, not Forge Lab, that like it's written in the program. So, now the app is looking a bit richer, a bit better, but there's still plenty of things missing. We have JBoss Forge has created all the backend, all the CRUD applications. Now we want to start adding our expenses. So now the problem that I have is I need like a wizard, something where I have a first page, I create one expense and click OK, and another expense and another expense and a recap at the end. So that's 2 pages. So that's like a wizard.
Yeah.
And also the login and logout. When I log in as a user, it spans for a longer time. And during this session, I can create as many expenses as I want. So now I need to deal with life cycle and beginning of a session and end of.
Yeah, CDI can help you here with the.
Brilliant.
Yeah, there is always an answer when you have a problem with CDI for your programming problem only. So you need to learn a bit more about context in CDI to go further in this use case. So we saw all the stuff around, related to bin type, injection point, etc. What we need to learn now is the concept of scope and context. So all the bin you define in CDI will have a scope that will be applied on the bin with an annotation. Each of the scope is associated to a context object. So with this scope annotation, your bin is bound to a context. Context are, how to say, are containers in charge of creating the instance for your beans. And the container is in charge of creating, destroying context, or say, okay, this context is active or inactive. In CDI, you have a bunch of built-in scope and built-in context that comes out of the box. The most obvious scope is probably the dependent scope. So it's the default scope. When you create a bin without an explicit scope, it will be dependent. So in fact, it means that the bin with the dependent scope will have the scope of the bin in which it will be injected. So most of the bin we saw in all the slides before were in dependent scope because they hadn't scope annotation on them. The second scope available in CDI is the application scope. So the application scope say, okay, this bin will be created when the first time it is requested for all the application, and it will be used for all the application lifecycle until the application is undeployed. The session scope is a scope linked to the HTTP session. So you have a bin created when a session is created and destroyed at the end of the session. Same for the request scope. So you have this scope linked to the HTTP request and linked to other specific use case, but let's say that for the sake of our university, it's linked to the HTTP request. And you have something that can be of interest for you, Antonio, is the conversation scope, which is a life cycle that you can control manually. So you can control at the programming level when this scope starts and when it stops. You see all the other scope are automatically started and automatically destroyed. The conversation scope is programmatically start and stopped. What you have to keep in mind is the fact that an instance of the bin is not created when its scope is, when its context is started. It is created when it is first requested and added to the context at this moment. If later you ask for a new instance of this bin and the context is still existing, the container will give you the same instance. If the context was destroyed and a new context of the same time was created, for instance, let's say a request was created, you will have a new instance, and so on. And of course, the CDI SPI allows you to create your own custom scope. So other specification already done that. If you look at the JSF specification, for instance, they created the view scope and the flow scope, I think, on the CDI SPI, and they created their own scope to extend CDI for their own use case. So a bit of example here. When I define a bin without any annotation, it will have the dependent scope. If I add the request scope annotation, so the bin will be bound to each request. So it will created in the limit of in the bound of the request when I request for it for the first time, and will be destroyed at the end of the request of the application scope if it's for all the application lifecycle. And of course, another magic point in CDI, you don't have any problem to inject bin coming from a shorter living scope into a long living scope. So here, in the last example, we are injecting the request service bin in our application service bin, which is an application scope, living longer than the request normally. But there is no problem. When we'll use your application service, you will get the right request service bin, the request service linked to the current request. So as I say, you keep in mind that instances are created when first access, not with their context. You have to think about the context as a mean to enforce the singleton pattern for a context. So the context is in charge to make sure that a given instance is a singleton in the current context. You have in CDI 1.1, and we probably will use it later, you have the possibility to manually destroy instance in a context. You can have sometimes the need of destroying a bin instance without destroying the context. You can also have a context existing but inactive. So for instance, you have a web application, you have so an HTTP session and the context linked to that, the HTTP session, but right now you are doing something else, like calling an asynchronous treatment, consuming a REST endpoint or something like that, and the session is not active. Yet it's still existing somewhere, it wasn't destroyed, but you cannot access the bin at the moment because you are not in the context of the session. And as I say, request context is more than just a mapping of servlet request lifecycle, but let's say for the university that it's the request lifecycle. So let's go back to your use case, Antonio. So I think you will need to use this conversation scope stuff. So as I said, the conversation context is a context that you can control the life cycle. Decide when it started, when it's ended, and have a way to define, how to say, a sub-session for your application. So the conversation can be used without being started, so it's transient, and you can promote it to long-running conversation. We showed that right after. And we will do this promotion to long-running with the begin method, and we will end the the context with the end method. And you can have multiple conversations in the same HTTP session. The common use case is to have multiple windows or tabs open in the same application and have different data in the different windows, for instance. And you can use the layer will send you an ID that will be used to retrieve the current conversation when you use conversation. So, as an example, if we create a wizard bin, we can put it in the conversation context with the @conversation scoped annotation. In this bin, we'll inject the conversation built-in bin to manage the conversation. At one point during our application, we will be able to decide to start the conversation, add information to the conversation context through bin or other things, and at one time in the life of the application, decide that, okay, this conversation is over, let's end it, and the context will be destroyed, and all the instance in the context will be destroyed as well. So I think now you have enough information to try to implement this conversation context stuff.
Yeah, it looks like it's the right tool. So this is what I've done while you were talking. I've created an expenses bin. So the idea is I have these 2 pages. I add the expenses, so that can take a while, and at the end I recap. And once I confirm my expenses, that's the end of the conversation. So this expenses bin, I just had the conversation scoped, so I know CDI will look after the life cycle of it. And then I have to do 3 things. First of all is I inject the conversation API. And then I need to start somewhere, and then I need to end somewhere. So what I do is each time I click on the add button, I want to start my conversation. But if I do that every time, it will be a different one. So there's a little trick here. I've injected the conversation API, And the first time I click on the add button, I go, is the conversation created? Is it transient? If it's transient, I start it, and I can initialize stuff. So the first time I'll click on the add expense, CDI will begin a conversation, and so I can click add as many times as I want. It will only create it once. And then at the end, when I recap, I need to end it. So when I confirm, when I click on confirm, I will end this session, this conversation, sorry. So this is how it looks. So I'm on the first page, add new expense. I choose the conference, Devoxx Belgium. It's in euros. I pick up a date. I'm saying the hotel. I have stayed in a hotel for 234 euros, 3 nights at the Marriott Hotel. I click on add expense. A conversation is created. I add a second expense. Restaurant for 345. Good food in Antwerp. So that's a second expense. And the conversation has been created once. I click on recap, so that's the second screen. So the beginning of my wizard was the first time when I add the first expense. And now I'm on the recap, and I can see these 2 expenses. I don't know if you see it on the URL, but I have this conversation ID, number 2. That means that I'm going to cheat a little bit on my URL. So that's what I have in my conversation 2. I have 2 expenses. If I open another browser, another tab, sorry, and I add other expenses, let's say for Devoxx UK, it's in pounds, but hey. And I go flight. So here I only had 1 expense. I recap. And I have a conversation ID equals 3. So now what's interesting is, as you can see here in the URL, I have a conversation ID 2 with 12 expenses, conversation ID 3 with 1 expense, conversation ID 2, so I can go back and forth, conversation ID 5, oops, conversation ID 2. And now I confirm the conversation is ended. So if I go back to conversation 2, oops, it doesn't exist anymore. But I still have conversation 3. And I confirm. Okay, so CDI as, you know, I've marked the beginning and the end. Everything, all the data is stored in a conversation until I finish it. So that's good. But now I have another problem, is when I log in, like admin, I want this session to longer. You know, the conversation, I have a beginning and an end. And when I log in, I want to be able to log in, span, and log out. So can I do that?
Yeah. Yeah, that's a good question, because you have a lot of magic coming with the context feature in CDI. But this lifecycle magic can sometimes have some drawbacks. You see, when you want to log, you'll probably use a bin in a session scope, and you don't have the control on the session scope. So by default, the bin you created in your session scope will be destroyed at the end of the session. What you might want to do is to get rid of this instance, but keep the context running. You want to keep the session, but you want to remove the bin in the session. In CDI 1.0, it wasn't possible to do that. It was not very easy to do that. Since CDI 1.1, you have a programmatic way to destroy a bin instance in a given context. If you want to do logout, you have two solutions to do that. The first solution would be to invalidate the session. So here, what you are doing is getting the HTTP session, call the invalidate session method, and to make sure that the session was totally destroyed, you have to launch a new HTTP request, so do a redirection to be sure that it works. That could solve the Antonio problems, but by doing that, you are killing the session. So you might want to keep the session active. And it's not a very good practice to, in your business service layer, to call UI stuff to perform business issue in the use case logout. So what you can do is to do it in a CDI way. So you will do that by using the instance interface. So what you can do is in a given bin, inject an instance of the bin itself. So here in the account bin, I can inject an instance of account bin. And I have this destroy method in the instance interface, and I can give the destroy method an instance. So here I ask the instance interface to get an instance, and I say, okay, destroy myself. And you can continue and be sure that the current bin instance was destroyed for the current session. So perhaps you can try to test that. Yeah, I know it's a bit weird and tricky, but it's working.
Okay, yeah, I think I'm going to use that because you know, I could use the HTTP servlet to request and use all the logging mechanism, etc., etc. But I'm going to try to keep it simple this time. So my account bin is in session scope because I know who is logged in. So I want to begin this bin when the session starts and finish it when I log out. So the account bin is in session scoped. So what I'm going to do, as Antoine suggested, is I'm going to inject an instance of me, so account bin. I'm going to call it me instead of my instance. So that's me. And
that's you, yeah.
I have a button when I log out. And in this button, I want to end up this session scope bin. So what I'll do is me destroy, so that's a new method in CDI 1.1. But I still have to get the instance of me. So me destroy, me get. I love that. Me destroy, me get. So when I deploy, here I have a connection. So the session starts. I log in as a Goncalves, so I know it's me. I only have users access, so I can only create expenses. And when I click on log out, CDI gets rid of the account bin. So it basically ends the session scope of the account bin. And now I can log in as admin. And the admin can see all the expenses. So I quite like that. It's not a completely login and log out feature, of course. You know, we could have gone to LDAP directory, a database, and check the roles and do all these little tricks. But here it's quite simple. You just get an instance of the session bin, and you get rid of it. So yeah, okay, it looks like it's working. Now I have another use case when I I log in as a user, and I create my expenses. My company told me that I should use a REST service that will take the, when I recap here, oops, sorry. Here I can change, I can ask to be reimbursed in euros or in US dollars. So here, I will show you, I have a bit of code that goes on the internet and takes this, you know, so I go to a currency layer, so I go on the internet, it grabs a bit of of JSON, and it will get the rate between euros and dollars. So I have that, which is good, but the internet here at Devoxx is not very good. So I would like to be able to say, well, while I'm at the conference, I want to have a fixed rate, and I can unplug that when I'm in production and go and pick up the REST service. So is there an easy way in CDI to say, inject this instead of that?
Yeah. The first answer could be, okay, create another bin with a qualifier. But if you do that, you have to change your code everywhere. And when you want to switch back to the original bin, you have to change the code back everywhere. So you have another feature that helps you to do that, to replace a bin by another one without changing injection point. It could be useful for a test or the use case Antonio gave. You have the alternatives feature. So an alternative is a bin that must be explicitly selected. So you have you create the bin, but it's not active. You have to say, okay, now I activate this alternative. When you have this alternative activated, so when it's selected, it supersedes the bin sharing the same type. So it will take over the bin regarding the resolution. In fact, in the type safe resolution we saw later, at the end of the type safe resolution mechanism, you'll have two bins eligible for the injection point. But CDI will check for the alternative feature on every bin, and if one of the bin has the alternative feature, it will be resolved. It will be this one that will be chosen. So it's the convenient way to create mock for your test, or to create specific implementation for a specific environment like we need here for Devoxx. You can activate your alternative in the bin XML file with the add priority annotation. I think here we will use the bin's XML file, which is more convenient because you don't have to change the code to do this activation. So let's check an example for alternative. So here, I took the use case of having a service to exchange data with an ARP application. So I have this ARP service interface, and I have my implementation for SAP. And it's a very heavy service, a very slow and impacting service. So what I might want to do is, when I'm developing the service and working on testing, I want to have a mock on this service. So I create an alternative which implements the same interface, but that mock all the method in the service. And I add the alternative annotation on this new bin. Somewhere in the application, I'm injecting the ERP service, and I want to have the right one. So if I didn't select the alternative, I want the SAP service implementation, and if I have selected the alternative, I want the mock SAP service implementation injected. Sorry. So as I said, we can do that with the @priority annotation. So you have to change the code to do that. So perhaps it's not the best for all the use case. By doing this, you also have the possibility to have multiple alternatives and give the priority for each alternative. So say, okay, you take the alternative with the lower priority to inject in the injection point. What is more interesting is that the fact that you can do that in the beans.xml file, so you can select your alternative in the files and say, okay, I have a configuration here for my current environment. I want to activate this alternative. So here I'm doing the same thing in the both place. Another interesting feature, which is more or less linked to alternative, is the stereotype feature in CDI. So in fact, stereotype is a way to have alias for annotation. So we didn't saw that in the new application yet, but you can have bin at the end with a lot of annotation on them, with the context, with the alternatives, with the qualifiers and multiple qualifiers and so on. So you can have a bunch of annotation. You can fall into an annotation L. Creating, yeah?
I have a question.
Yeah?
I guess that beans annotated with alternative do not cause ambiguities.
Do not what?
Do not cause an ambiguity.
No. Yeah. If you have been, your question was about the bin annotated with alternatives and ambiguities.
Yeah.
If you have bins annotated with alternative and you didn't select them, they are not taken into account when resolving the right bin for the injection point. You have to select them, and when they are selected, they supersede the original bins.
Even if my injection point is qualified?
Yeah.
Okay.
Yeah. But if your injection point is qualified, you also need that the alternatives should be qualified as well. In fact, you keep the same type safe resolution mechanism, but at the end, if you have multiple candidates for the injection point, the container will look if one of the candidates has the @alternative annotation, and if it's the case, it will be taken into account. If it's not the case, you have an ambiguity. So by using stereotypes, you have a way to define an alias for a bunch of annotation and avoid annotation L. And it's also a way to another way to enable alternatives. So, for instance, in our application, we have a lot of bin annotated with @conversation and @named. We can create a stereotype gathering both annotation. So we'll do that by creating a new annotation. Let's call it wizard. Let's add on it the meta annotation @stereotype, and we add all the annotation linked to this stereotype that will be contained by this stereotype. So we add the @named and @conversation scoped, and after that, we can switch the @name @conversation scoped annotation we had by the @wizard stereotype. You can use the stereotype mechanism for selecting alternatives. If you have a collection of bin, here we only saw a lonely bin in my example with the ERP service, but you can imagine having in a given environment a collection of bin. You can put a stereotype on them and say, okay, now I'm activating all the alternative with this stereotype instead of giving the class in the beans.xml.
Okay, so
you can try
I think I can use a few things. So, first of all, I'm coming back to my Wi-Fi problem here. So, as I said, I have a currency service that will take a currency, either euros or dollars, and compute it based on a rate, on a fresh rate. So it injects a rateable service, a rate service. So I actually have two implementations. One rate service actually does the job. So it takes a URL, creates a HTTP client using JAX-RS, reads the JSON stream using JSON-P, and gets the quote. So if I show you this service, I invoke this URL, the service gives me a timestamp, etc., but what I want here is quotes, and that will give me the rate range from US dollars to euro. So quotes, I will get quotes and the number USD euros. So the rate service actually goes online, goes on the web, picks up that and translates. So if I show you the demo, so here I'm logged in as Antonio, and I'm going to create a new expense. Okay. Expense, and when I do the recap, you're going to see this number move slowly.
Slowly.
Because it connects on the web, bring back the rate. So you see there's a little lag because it actually goes. And so what I want to do is I'm doing a demo and I don't want this lag. So I've created a service mock, a rate service mock. So both rate service, the real one, implements this interface, and the mock implements this interface. But it's an alternative. This is the alternative implementation of the rateable interface. And to answer back your question, we could have done that. Currency, inject me the rateable for euros. So that's a qualifier. And I could have gone, well, this is the rate service for euros. And this is the alternative for euros
as well.
That's what I could have done. Okay, so now I have this alternative. By default, alternatives are not enabled. So now I go back to the bins XML. I enable this rate service mock. I deploy the application again. And you see I've used a crazy number, so 99.99. That's, if we have this exchange rate, it's either because Europe is going down or the US. We don't know in which. So let's not hope for such a rate. And now, if I create an expense, by enabling this alternative, I won't go online, call the REST service, blah, blah, blah. I will just use the mock, BIM. Okay?
Yeah, and the good part here is that you didn't have to change your business code.
And my business code didn't change. I still inject a rateable. So that's the nice thing is, the alternatives, it's like the bridge design pattern. And by enabling a few, you can just change parts of your algorithm. And something else that while you were talking, I remember going to a spring talk, and I think they were bitching the EJBs, and they came with this fantastic thing, because all our services are transactional and loggable. So I actually created a service, like in Spring. So I'm saying a service is a stereotype, meaning that it's transactional and loggable. So I could have even created a repository, or a component, or a controller, or something like that. So that's an easy way to cheat a little bit. So from now on, all my service will be annotated by service, and my wizard page will be annotated with wizard. A wizard, it's named and has a conversation scoped. So my, you know, I have my famous conference bean, which is now a wizard. So the demo you've seen already used the stereotype. So far, so good. So now I can create expenses, I can log in, log out, I can use password encryption depending, you know, whatever I want. So I'm nearly at the end of my use case. There's now a few things that have to be done. When I create a reimbursement, so when I confirm, I want to tell my billing department that it needs to bill, and the banking department that needs to pay someone. You know, the user went to the conference. So now what I want to do actually is my banking service, I have the code and I can change it a bit, but it's not really my code. You know, there's other guys working with that. So I know I can inject it. You know, I can go inject the banking service and go, please do whatever you need to. But then I have a problem with the billing service. The billing service, I do not own the code. I just have a jar file. And I would also like to, you know, tell these guys that they need to do something, but because I don't have the code. So, you know, I have these two services now. I need to interact with them, but they have different life cycle, it's different teams. So how can I inject those services, but in a looser way?
Yeah, okay. You probably won't want to inject them. You will use events. You will use this other way to decouple your code with the producing and the consuming part of your code. Events are a very nice feature in CDI, very popular feature in CDI. It's rather easy to use this eventing stuff in CDI. So you only have to inject the event interface, and it's a parameter as type. So you can say, okay, I'm going to deal with event of anything, any class I have in my project. So it doesn't have to be a bin, it shouldn't be a bin. So here, for instance, I have an example of, let's say, a blog application or something like that. So I have post in my application. So I am injecting an event of post, calling it post event. And somewhere in my code, I can use this event firing system and call the fire method. So here I'm firing the post I'm saving. So when I save a new post, I'm firing it. And when I do that, I don't know if something somewhere is listening, but I don't care. I'm sending this information, and there could be one observer, two observers, zillion observer, and I don't have to change my code. I only gave a way to notify anything that can be listening to this information. So here I have a second bin listening to this event. So I have a method in this second bin called listen post, and there is this @observes annotation in one of them in the method, and I'm listening to the event of type post. I'm listening to this event, and I'm doing whatever I need to do, and that's it. So all the eventing system is also based on type-safe resolution based on type, and we have roughly the same way of resolving event and observers that we have to that we use to resolve injection point, for instance. See, as I said, yeah, the observer resolution is very near the type-safe resolution. The only difference is that we will accept observers without qualifier will be triggered by event with qualifier. So if we take this bunch of examples, so here I have this bin firing an event with the French qualifier. You see, I'm using the annotation literal again to add qualifier on my event. So most of the observer will be triggered by this event. In fact, the three first one will be triggered. The first one because it has the French qualifier and the right type. The second one will be triggered because it has a subset of the fired event, including the empty set here. So we don't have a qualifier, but it will work. The third one doesn't have a qualifier, but it's the same use case, and have a type in the type set of post, because object is the ancestor of all object. But the last one won't be triggered because it doesn't have a qualifier that was on the fired event. You can use event to do a nice thing. For instance, you have all these observers that can be used to observe the beginning of a context and the end of the context. So for instance, if you take the observes at initialize of application scoped, it's a way to start a bin when the application scoped, the application context is started at the beginning of the application. So it's a way to instantiate a bin at the beginning of the application. Okay, so now you can use your knowledge on observers to resolve your first problem with the code that you...
Looks quite easy, so let's see if it works. So here I have my banking service. So as I said, it does plenty of things. So once the reimbursement is done, when I have all my expenses and I say, yes, please reimburse me, I call this banking service, which, as you can see, does a lot of complicated things. I kind of do own this code. You know, it's in my repository somewhere, so I do have access to this code. This is my application. So when I create a reimbursement, I persist it in the database. So what you're telling me now is I can inject an event. So there's an event API, and I have to type it. So yep. I'm going to throw a reimbursement. That's going to be my event.
Okay.
And once I persist in the database, so I go event, I fire. So I fire what I've just persisted in the database. Okay. So on the other hand of what my class path, my cluster, my whatever, I observe this event. Here I only have one, but again, same thing. I could have used a qualifier like Antoine showed you. So as you can see, this banking service does logging. And it waits a bit. It waits for 5 seconds because, you know, it does a lot of banking. It needs to double check the bank account and so on and so forth. So there's no bins XML this time, no. So I do not have to activate anything.
Working out of the box.
So I deploy the application and I log in as a normal user, not as an admin. I'm going to create new expenses. Okay, a restaurant. I recap, and now when I confirm, that's going to fire an event, and hopefully I'll see the logs here if it works. So confirm. Oh, It hangs.
Yeah, in 5 seconds.
Oh, yeah, it hangs because it has to wait for 5 seconds. And yeah, so here I have all my logs. So that was quite easy. There's no JMS involved. There's nothing. There's no reliable messaging. It's just the observer needs to be in the class path, so you can't have an observer on the opposite side of your cluster. But here I just fire this event, and I just need to add an observes annotation. So that's good, because the banking service, I have the code here, but the billing service is from another team, and I don't even have the code. I have the Java doc, I have the jar, so I can depend on this jar, but I don't even have the source code. So how do I, how can I fire this event to guys that I don't even own the code?
Yeah, the feature you'll need here is to build an extension. So you'll use the extension mechanism to add a feature to code that is not your code. Portable extension is probably one of the most powerful features in CDI because it allows you to extend the platform in very seamless way. It's not yet very popularized because to build an extension you have to have a deep knowledge in CDI. There is still lack of information on extension, but we are working on that. And there are a high level of abstraction in an extension development. But when you are used to it, you can build very powerful stuff. So for what reason would you like to create an extension? The first would be to integrate third-party library, framework, or legacy component. In our case, it's legacy component integration that we don't own the code and don't want to touch the code. We can also use it to change configuration behavior in existing code. So have something specific in a code that you want to activate once without changing the code. It's also a way to extend Java EE, as CDI is used by a lot of specification in Java EE. A lot of specification rely on CDI, so you can integrate new stuff in Java EE platform through extension, and it's a way to add new stuff to the platform between two Java EE major release. So the often said critics on Java EE saying, okay, we have to wait 5 years between two major releases. Now it's less true than it was because you have this CDI extension point that allows you to add business stuff or new feature to your Java EE server. So how to build an extension? You have a set of events triggered at the bootstrap of your container, and you can observe this event. So it's all based on the eventing system. You can observe this event to check all the metadata, meta model that were created by the container. So you can look at them, change the metadata, and replace them if you want. And if you want to go more concretely, creating an extension will require the creation of a new file, because it's based on the Java service loader. You have to add the Devoxx Enterprise Inject SPI extension file in your meta services directory. And in this file, you will add the fully qualified name of your extension classes, and that's it. An extension classes is a class that implements extension interface. It's an empty interface. It's only an interface to indicate it's an extension. And in this class, you will observe one or more of these events triggered at container bootstrap. So if we look at the container lifecycle, you have a lot of steps in the bootstrap of your application. So here in the diagram, you have 3 types of step. You have the gray one, it's the step that you don't have hook on them, but important, it's internal step. You have the step in red that happens once, and you have the step in blue that happens in loop on a collection of type, bin, etc. So the first step when you deploy your application is before bin discovery. In this step, we will be able to add new feature to your deployment. So to add class coming from external jar, for instance, to say, okay, I want this class to become a jar, to become a bin if it's possible. After that, you have all the mechanism of type discovery done by the container, and for every type, you will have a process annotated type event triggered, so you can observe and change the annotated type, decide that this annotated type won't become a bin, etc. When all the annotated type discovered, so all the type were discovered in your application, you have a step where you can do something with all this collection of types. So decide that something is lacking, so you can add things because you didn't discover a class having this interface and so on. And after that, the container will start to check eligibility for each class to become a bin. And we have the process of creating bin that will be done after that. After that, we have an event for all injection points discovered in your application. So we will have the possibility to detect what is how each injection point is defined, qualifier, types, etc. We have the same for injection target, which are not specifically bin, but it's component that can inject over CDI bin. It can be servlet, it can be entity listener and GPA, etc. After that, we have two phases linked to bins. So the bin attributes and the bin themselves. So we can change the attributes of each bins and decide that we won't let this bin be added to the collection of bin. When all the bins were discovered, we have information about things that are internal to the bin, so that would be the producer. So we have an event triggered for each producer discovered in every bin. The same for observer method. So you saw the method with @observes annotation. So we can work on all observer method. After that, we have a last step, the after bin discovery, where we can change things regarding bins or adding new stuff, etc. It's the last step where you can change the metadata regarding your CDI application. After that, the container will be in read-only mode, so you won't be able to add bin at runtime or things like that, but you will be able to get as many instances as you want, but no change the metadata. After that, your application is running, and you have a last event you can observe is the before shutdown event, where you can do cleanup and things like that. So a very simple extension example here. So I have this veto entity extension. So it's commonly not a good practice to mix GPA entity and to use GPA entity as CDI bin. So we could, we would like to say that every entity discovered in deployment won't be a bin. So we have this extension. In this extension, we observe the process annotated type for every type existing in the deployment. And there is this @with annotation, magical annotation, saying, okay, I want to observe all type that have the entity annotation on them or in them. So it's a way to catch all the class with @entity on them. And for all this process annotated type, I call the veto method, saying, okay, I don't want this annotated type to become a bin. That's very straightforward and quite easy to understand. So you have to keep in mind that extensions are launched during the bootstrap, the deployment of your application, and they are based on CDI event, like you just saw with the @observes annotation. Once the application is bootstrapped and running, the bin manager is in read-only mode, so you can't add a bin at runtime. And to build your extension, you only have to observe built-in events. So the trick to have a better understanding of your extension, of the extension possibility, is to have a better understanding of the SPI. So I'll try to show you in a few minutes the content of the SPI. I won't go into too much detail to lose you, but it's quite important to understand that. So we have roughly 4 parts in the SPI. The first is the part linked to the type meta model. The second part is the part linked to the CDI meta model. After that, we have all the class linked to the CDI entry point, how to enter in CDI, how to deal with bins, etc. And the last point is the SPI dedicated to extension. We already saw a few of this SPI point with the @observes process annotated type. Process annotated type is an SPI dedicated to extension. So if we start with the type meta model, why would we want to have that? Because as you saw in CDI, we use annotation as configuration. So it's interesting to read configuration, but we might want to write configuration. But if you go to the reflection library in Java, you see that everything is read-only. So we need a meta model to map all the information on the classes and be able to change them. So we created in CDI this annotated and annotated type concept to map all the information on a given type. So this SPI part for the type meta model, I won't go into too much detail, but it's quite easy to understand. In fact, in the center of the SPI, I have the annotated type, and I have all the part of the type in the SPI. So I have the parameters, the method, the field, etc. So it's you should see that as a mirror of all the class in the reflect package, method, field, etc., but in a writable way. And I could use this meta model to do something different than CDI stuff. I could use it to add configuration to other framework, for instance. After that, we have all the SPI dedicated to CDI meta model. So we already used the injection point. You can see up there on the right. We already use the bin. It was very fast, but Antonio injected a bin in his interceptor to get information, metadata of the bin. And there are other SPI that you can use, either on an extension or either at runtime. So we saw that we can use injection point at runtime. After that, we have all the SPI linked to the CDI entry point. So I won't go into too much detail there as well, but you see that instance interface was used in the context of CDI, but you have a class extending the instance interface, which is the CDI class, which have a static method allowing you to, from outside CDI, get an handle on the CDI container and request bin from outside CDI. So they're very convenient. You also have the unmanaged class allowing you to take a class that is not a CDI bin, but having @inject annotation and triggered injection in this class can be used to add information on the non-CDI class or class that is managed by another container, for instance. And of course, the bin manager is another way to get into CDI. And last but not least, all the events we saw before in the diagram with all the steps are there. So all these events are dedicated to extension, and you can observe this event to change stuff. You have to keep in mind that these events are a kind of vehicle for metadata. So for instance, the process annotated type is a way to bring to you a given annotated type. So you can observe the event to get the information linked to the event, so the annotated type, and change the nature of this metadata. So if we go back very fastly to the CDI meta model, I think that for your use case, we can use the observer method SPI class, SPI interface, and use it to register a new observer at boot time. So if we look at your Java doc here.
Yeah, so as I said, we have the banking service, so that's our code. And the only thing I have on the billing service is this Java doc and the jar file. So I do not own the code. So what I'm going to do now, so this is the banking service. The banking service observes the reimbursements. Okay? So that's what I showed. On the POM XML now, I just say that I depend on the billing service. So I do not own the code. It's just a jar file. So now I'm going to write an extension. As Antoine said, I take a class, it implements extensions, and now the only thing valuable that I have is observe an event. Which one? As Antoine showed you on the life cycle, I'm going to listen to the after bin discovery. So I deploy my application. It goes through the life cycle. CDI does this and that and discovers this and discovers that. And once all the bins are discovered, I go, wait a sec, I have something for you. So CDI at this stage, after bin discovery, has discovered all the bins. So I observe this event. Oh, CDI has finished. Now I can do some work. And what I'm going to do is I'm going to take this event, and I have a few methods. And here I'm going to say, I know you've discovered all the bins. I know you've discovered all the producers. I know you've discovered all the observers. I'm going to add an observer. So I call this add observer method, and I'm saying, hey, look, this is a new observer that I'm going to create. So this is a new class I've created. It implements observer methods, so that's what you were saying. I need to implement a bunch of methods. The bin class, well, it's the billing service, the one that I do not own the code. The observed type, it's a reimbursement. Remember that when I create my reimbursement, I fire a reimbursement. So here I'm saying, you will observe a reimbursement, and so on and so forth. But what's really important, it's at the end, when I'm notified. I'm going to create an instance of this new billing service that I do not own the code. I know there's a method called reimbursement to bill, and this method takes a username, a conference name, and the amount of the expenses. So here, in this method, I just invoke a method passing the needed parameters to code that I do not own. Last but not least, very important, you need to enable an extension. So the way we do that is the Java way. You go to services, meta-env services, and you just create the extensions file and you give it the name of the extension. So now I have two observers. I fire one event, the same event. The banking service is in my code, and thanks to extension, I will invoke the billing service, which is external. So if I go back to the app, I'm gonna create an expense. Here it is. And now when I confirm, I'm going to persist the reimbursement in the database, and I'm going to fire this event. So it hangs. But if I look at the logs, I should be, here is the banking service, so that's me. And it looks like the billing service is also very slow. Yeah. So this is the billing service. And then he, had... but the problem I have here is I'm not doing JMS or nothing like that. So an event, it's basically within the same class path. You notify someone, and it's in the same thread. So when I confirm, you can see it hangs. It hangs for 10 seconds. So that's the typical case where I want a synchronous call, and maybe the JMS would be easier.
It would do what you want, but it won't be easier.
Okay, so you have something else for me?
Yeah, we have a few minutes to introduce new things in CDI2. So we are talking about events which until CDI2 are synchronous. But in CDI2, we will introduce the asynchronous event. The good news is that you can test CDI2 today. There is a release of the reference implementation in CDI2. And in this preview, you have the asynchronous event feature. So here, it's quite the same than the previous example I showed, but we added the fire async method to the event interface. And for a backward compatibility reason, we have to add the observes async annotation. So we can easily change our code to fire an observes event in an asynchronous way. So I think we have everything we need to test an asynchronous event, Antonio. Why? Because we have this well-free alpha. We have a good news. This Wildfly has a patch mechanism allowing you to update implementation, and you have a simple command to enter to do that.
Okay, so let's go back to my reimbursement service. What you're saying here, it's instead of fire, I will go fire async?
Yeah.
That's all?
Yeah. And observes async at the end.
In my banking service, I have observes, and I'll go observes async?
Yeah.
Okay. And then with my extension, so here, I need to override another method.
There is a new method, isAsync here.
IsAsync, and I need to pass through. So that's my extension. Yeah. So now, you're telling me that's easy, and it should work like a charm. Well, let's see if it works. So I'm going to create a new expense. Okay, and instead of hanging for 10 seconds here, I'll just go, oops,
what happened? Oh, that's the demo effect.
Oh, wait a second, because I'm using Wildfly 10, which is Java EE 7.
Yeah.
So it won't work.
Yeah, you have to update your Wildfly. So use the patch.
I need to update Wildfly like that?
Yeah.
Okay, so I shut it down. I shut down Wildfly.
Yeah. So when we release a new alpha version of Weld, we also release a patch to the latest version of Wildfly. So you can update Wildfly and integrate this new reference implementation for CDI2 easily to test it.
So here I'm using Wildfly 10 CR4, the latest, greatest. I apply a patch, so I'm using the JBoss CLI, and I'm telling him, please use a CDI 2.0 instead of 1.1.2.
Cross finger. Okay.
Oh,
Wow.
Success. Okay, so I've patched Wildfly, and now, so I'm telling Wildfly, please use CDI 2. So it looks like it's a very modular system, and I can. And now, when I connect, create an expense. Okay, currency. Choose a date. Add an expense. Recap. And now I confirm. Oh, okay, so that was asynchronous.
Look at your,
And on the logs, billing. And banking should come later. Hey, okay, cool. So that was an asynchronous call with Wildfly patched and everything. So
free alpha.
the greatest, latest CDI 2.0.
So I think it's time to go to our conclusion because we have only 4 minutes left. So you can check all the information on CDI 1 and 2, CDI 2 on the cdi.spec.org website. You have all the
code is under GitHub.
slide and code
So we have all the demos, we have all the slides, everything is there. So you can have a look. If there's something you didn't follow, you can go back to the demos and diff between the code and see how it works.
Do you have questions?
Yep.
You said I can use CDI extension to add features to Java EE 7. So that means extensions are also scanned within libraries which I include in my application?
Yeah, so the question was, can we use extension to add more features to Java EE? And the answer is yes. That's exactly the way you do it. And actually, there's one very interesting use case is Antoine wrote an extension for metrics. So you just take the metrics library, you put it in your WAR file, and with this extension, you just add, a metrics annotation, and it will work. The same thing happened with JCache. I saw that, JCache is not in Java EE 7. It will hopefully arrive in Java EE 8. And the guys created an extension to have JCache out of the box in EE 7. So that's the perfect use case. 1 minute left. One last question. Or maybe you can come afterwards. Well, thanks, guys.
Thank you.
Thanks for attending the talk. We hope you've learned a little bit of CDI. Thanks.
Thanks.